Hey guys, today we are going to talk about some other congruence shortcuts. We talked about a couple last time that greatly reduced the number of things I had to show were equal in order to prove that two triangles were congruent. Okay, we looked at the side theorem and we looked at the side angle side theorem. Okay, today we're going to look at angle side angle, which is pretty much very similar to side angle side, except we're going to have an angle included instead of a side. So it says if two angles and an included side of one triangle are congruent to two angles and an included side of a second triangle, then the two triangles must be congruent. Okay, so it looks like this. Okay, I've got triangle MNO and I've got triangle TSW. Okay, so I've got angle M equal to angle T. I've got angle N equal to angle S, and I've got side MN equal to side ST. So this is an angle side angle situation. And when I get angle side angle, that tells me these two triangles must be congruent to each other. Okay? So I can write my congruent statement. Triangle MNO is congruent to triangle TSW. Okay. Now this one is a little bit tricky. It's called the angle-angle side theorem. Okay? And it says if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So this is one you got to watch out for. Okay, so here we have an angle-angle side situation. So I've got an angle, and then I've got a side. Angle, angle, side. Now what you need to be careful of is notice I've got angle with one mark on it, angle with two marks on it, then the side on both of these. Okay? So what you got to be careful of is that you don't have this situation. Okay? This would not be two congruent triangles, where this one went two marks, one mark, and then a side, and this one goes one mark, two marks, and then a side. Okay? It's got to be the corresponding side. So we'll back up here. Now we have, this is the side that corresponds with this one. Okay? Now we have two triangles that are congruent. This is the one that people make mistakes on the most often. Okay? Okay. All right, so here's the other example here. Okay, I've got an angle, angle, side, and I've got an angle, angle, side, but this is not the same side as this one. This is the side that's next to the side with one, or the angle with one mark. This is the side that's next to the angle with two marks. So notice this is a not congruent to situation. So be very, very careful of that. Okay, the parts of a right triangle. Okay. Notice we've got the 90-degree angle right here. Okay. The two sides that meet at the 90-degree angle are called the legs. The other side is called the hypotenuse. The hypotenuse is always the longest side of the triangle. Okay. All right, so be careful of that. The legs always meet at the 90-degree angle. And that's the parts, okay? Piece of cake. All right, hypotenuse leg theorem. This is another shortcut, okay? Sometimes it's called HL. If the hypotenuse and one leg of of a right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles must be congruent. So here's the situation. I've got a hypotenuse and a hypotenuse. I've got a leg and a leg. I've got a 90-degree angle. Okay, now this is, sometimes people look at this and they want to call it the side-side angle theorem. And here's the thing is, we don't call it side-side angle. It always works in a right triangle. It sometimes works if it's not a right triangle. Okay, when does it work? It works this way. If it's the big side, then the little side, then the angle, it will always work. Okay, so even if it's not a right triangle. So a situation like that would be, I've got a triangle like this, and I've got the big side, then the little side, then the angle. That will work. But if it's little side, then big side, then angle, it does not work. And let me show you why. Okay, I could have the situation like this, where I've got the little side here, the big side here, and then the angle here. Now look what I can do. I could have this triangle right here that has, where this is an isosceles triangle right here, so that's equal to this. This side here is equal to this. Now I've got this situation. And there we go. Now I've got two different triangles, and I have little side, then big side, then angle. Okay. If I have the big side, then the little side, then the angle, that's impossible for me to make those two triangles. Okay. So if I've got this, these have to be the same triangle, because I can't flip this this side around to the other side and make it work like I did here. Okay, if I try to flip this side so that it goes over here like this, I've now changed this angle that's over here. Okay, so the hypotenuse leg is an example of big side, little side angle. Big side, remember the hypotenuse is always the biggest side of a right triangle, so big side, little side angle. I can't flip this anywhere. It won't go anywhere because this is a 90-degree angle, so it doesn't flip like this one did from here to here. Okay, so hopefully you'll be good with that. You're always safe when it's a right triangle. You're always safe if you do big side, little side angle, but if you do little side, big side angle, those are not congruent triangles. That is not a triangle congruence theorem. Okay, so here you go. There's your assignment. Talk to you later. Have a great day.